Hi everybody, this is your last video lesson of your first week, and this is our probability test review. Now before we get into this, just one quick thing while I have your attention. Some of you have asked me how you're supposed to do the probability assignment, and you have two options. You could download it and print it and answer right on there, and then, as you normally would, take pictures of it and upload it to D2L. If you don't have a printer, that's okay, or if you don't want to waste your printer's ink, that's perfectly a-okay. Just download it, be looking at it on your device, and answer all the questions in order on line paper. You don't have to copy, if you're doing it that way, you don't have to recopy down all the questions or recopy them out. Just do all the solutions, but make sure it's very well labeled. So like, this is section number 1, this is question 1, this is section number 2, question 2, and so on. So make sure it's organized, it's neat, it's labeled. Make sure that anywhere where it asks you to color something or draw a picture or something, there's a couple sections where you have to color things and draw some things. Just make sure that you do those as neat as possible and just do it in the exact same order that you see it. And again, this is a creative assignment in addition to testing your knowledge of probability. And if you've noticed on the very last page, there is a marking rubric where it's out of 50 and 15 of the 50 marks are for your creativity, neatness, your design. But again, this is your own amusement park. You should not have anything remotely close to anybody else. It's your own assignment. So with that being said, we're going to get into our test. So our first example, state the possible outcomes of the following situations. So what are all the possible outcomes if you flip a coin twice? And order doesn't matter here. I mean, what order you put these in, but you could get 2 heads. You could go heads, tails, or you could go tails, heads, and then tail, tail. And that's it. All of the possibilities of rolling a die greater than 2. Assuming it's a normal 6-sided die, you could roll a 3, 4, 5, or 6, and those are all greater than 2. If you randomly answer 2 true-false questions, again, order matters. So you could answer, let's say, true, true. You could answer true, false. You could answer false, true, or you could answer false, false. The outcome of a hockey game. We're just going to keep it simple. So actually, we'll do a simple and we'll do a more complicated one. So simple, you could win or you could lose. If we want to be super precise, you could also have a shootout win, a shootout loss, an overtime win, or an overtime loss. Number 2, complete the following chart for the sum of 2 days. So remember during your lesson, I said this is going to pop up again, and here we are doing it again in our review. You have to remember sum means add. And then those are the options for die number 1. These are the options for die number 2. So if you roll a 1 and a 1, that adds up to 2. If you roll a 1 and a 2, adds to 3, and so on. All you do is adding these up. So take a second, make sure you add these up. So if you add, you can't get anything under 2 and you can't get anything over 12. Now I'm going to go to the next slide, but you guys will have this in front of you to use to refer to for our next set of questions. So using that chart we just came up with, state the probability of each situation as a decimal. So getting a sum of 9. Remember, you're being asked for a probability, so don't forget, if you don't want to throw away easy marks, we can cheat a little bit. Capital P for probability and brackets, what you want to find the probability of. And then taking a look at your chart, how many 9s are there? 4 out of. And one thing we forgot to write, how many outcomes are there on that chart? If you counted them all up, or you went 6 by 6, everything should be out of 36. And we want that as a decimal, and we'll round to 2 decimal places. 4 divided by 36, we'll say 0.11. Getting a sum of 4 or 12. Probability of that equals, how many 4s or 12s are there on there? Count them up, you should get 4 out of 36. We're going to know the answer to that, 0.11. Getting a sum on 2 dice that's an odd number. If you don't remember what an odd number is, 1, 3, 5, 7, 9, 11, and so forth. So if you count up all the odd numbers, you should get 18 out of 36, which equals 0.5. Hopefully that makes sense. I mean, odd numbers are every other numbers, and even numbers are also every other number. So it would make sense that half of them are odd. If I was to ask you how many are even, that would also be half, right? 18. And the last one, the probability of getting a sum of 12. How many 12s are there? There's only 1 out of 36, so it's extremely unlikely. 2 decimal places, 0.03. Number 4, just some quick true-false. The probability is a measure of certainty of an event occurring. True. To calculate experimental probability, all outcomes must be equally likely. False. Probabilities can never be a number bigger than 1. True. Remember, if it's 1, that means it's guaranteed. That's 100%. Experiments can be used to estimate the probability of an event. True. And as the number of trials increase, experimental probability gets closer to theoretical. We talked about that in our first lesson. That's true. Small sample size, anything can happen. The larger the sample size, the closer it should get to what should happen theoretically. So that is also true. Our next example, complete the following tree diagram for flipping a coin 3 times and write out each of the possible outcomes. Remember, we stressed this. We did quite a few examples. You need to know how to do a tree diagram. And we usually use this for things where there's more than one thing happening. In this case, there's 3 things happening. You're flipping a coin 3 times. Or I could say, take 3 coins in your hand and flip all of them at once. First thing for a tree diagram, write out the headings. So we'll say coin number 1, coin number 2, and coin number 3. And then there's our possibilities or outcomes. What are the possibilities for coin number 1? Heads or tails. Same thing for all the coins, but don't forget your branches. So coin number 2 could be heads or tails. Heads or tails. And then coin number 3, same thing. Heads, tails, heads, tails, heads, tails, and heads and tails. So there's our tree diagram. Don't forget our outcomes. Remember, you start on the left, so start here, and then work your way across. So H, 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 then trace through H, H, T, H, T, H, H, T, 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 H, H, T, THT, TTH, and triple T. And count all of your outcomes. 1, 2, 3, 4, 5, 6, 7, 8. All probabilities are out of 8. So that means if you flip 3 coins, or 1 coin 3 times, there are 8 possible ways you could do it. Now we're going to use that tree diagram to determine each probability. So let's just cut to the chase here first. Probability, just so we don't forget. So what's the probability you get to, I'm just going to color code this, that you get 2 tails. So go through our probability. Okay, there's one that has 2 tails, that has 2 tails, that has 2 tails. And the last one actually has 2 tails as well, right? Otherwise, I would say getting exactly 2 tails. So we got 1, 2, 3, 4. So 4 out of 8. And remember, as a fraction, we want that reduced, which is 1/2. And as a percent, that's 50%. B, getting exactly 1H. So exactly 1. So no, no, yes, 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 yes. So getting exactly 1H, there's 4 of them. 4 out of 8, which again ends up being 1/2 and 50%. Getting exactly, oh, I did that, I read that wrong. We're going to switch these, I'll erase them, I skipped ahead and read C before I did B. Sorry about that. Getting at least 1 head. So at least 1 head could be that one, that one, that one, that one, that one, that one, that one. Basically all of them except for the last one. So 7 out of 8, which that's already reduced. And then as a percent, 7 divided by 8 times 100, 87.5%. And then we already did the exactly 1H, which we got 4 out of 8 and 50%. And then our last one, getting tails on the second coin. HH, okay, so there's 1, there's another one, there's another one, there's another one. 4 out of 8 again, which is 50%. And don't forget we want those reduced. So that's 1/2, and that's also 1/2. Hopefully that makes sense. Again, can't stress this enough. Make sure you know how to do a tree diagram. Our next example. A bag contains 5 red marbles, 2 blue, 4 yellow. If you draw 1 marble out randomly, what's the probability of getting each event? So, again, so we don't forget, P for probability in brackets of what you want. So first thing you should do, how many marbles are there? 5 plus 2 is 7 plus 4. All of these are out of 11. Getting a blue marble, 2 out of 11. And again, I didn't tell you for this question fraction, decimal, or percent. So you could do it however you want. I'm just going to leave it as a fraction. Getting a green marble. How many are green? 0 out of 11, which equals 0. 0% chance. Not getting a red. So everything that's not red. Well, if there's 5 red, 2 plus 4 is 6. 6 are not red. Number 8, a sock drawer contains 15 pairs of socks. 6 of the pairs are white, 4 of the pairs are brown, the remaining are black. Determine the probability of, don't forget these, and I keep stressing it, I know I sound like a broken record, but Every single time there's multiple students that forget to do this and they're just throwing away needless communication marks. Getting a pair of socks that are brown. How many of them are brown? 4. 4 of the pairs of brown out of 15. I didn't tell you how to express your answer, so you can do fraction, percent, or decimal. I'm going to leave it as a fraction. Remember, the potential for error, though, if you leave them as fractions, make sure you're good at using your ABC button or reducing fractions. Getting a pair of socks that are not black or brown. If they're not black or brown, that means they're white. How many of the pairs of socks are white? It says 6 out of 15. And if we leave it as a fraction, reduce it, 2 out of 5. Getting a pair of socks that are pink. How many of them are pink? Well, you have white, you have brown, and you have black. There's no pink. So 0 out of 15, which equals 0. It's impossible. Our next question. A bag contains 70 poker chips, 35 purple, 10 red, 25 orange. Jesse draws a chip, records the color, returns it to the bag. The results are shown in the graph. What is the theoretical and experimental probability? So let's just probability. And I'm going to do the theoretical first. So I'm just going to write Theo here first. So theoretically, 10 are red out of 70. 10 out of 70, leave it as a fraction, 1 over 7. Purple, there are 35 out of 70, theoretically, that reduces to 1/2. And then orange, there's 25 out of 70 chips. And if we reduce that, you should get 5 over 14. And again, you have choice if I don't tell you. So if you don't like fractions, you can make those all percents if you want. Now we'll do the experimental, which has to do with what Jesse got. So if we look at the graph, Jesse actually got... Now the first thing you're going to want to do is see how many times he drew a chip. So you have to add up those numbers on the bar. So 14 plus 20 is 34, plus 23 is 57. So we know that this is going to be out of 57. Remember, this is not out of 70 because it's not the theoretical. This is what Jesse witnessed out of his 57 draws of the poker chips. So he drew red, which is right there, 23 out of 57 times. And then just double check, make sure that doesn't reduce anymore, or make it a percent. It doesn't reduce. Purple, right there. He drew 14 out of 57. Again, make sure that doesn't reduce, or make it a percent. That does not reduce. And then orange, which is right there, he got 20 out of 57. Which again, make it a percent or reduce it, does not reduce. Now, seeing those as fractions doesn't necessarily help you, but if you were someone that made a percent, and I didn't ask a follow-up question to this, but if I did, I could say, did red do better or worse than theoretically? Or did purple do better or worse? Or were you lucky or unlucky with the orange? So keep that in your back pocket. A basketball player made 15 of the 26 foul shots he took in 4 games. So this is kind of tying in our last lesson on using probabilities, in this case sports. How many shots is he likely to make in his next game if he attempts 10 foul shots? So what we want to do first is we want to figure out what his accuracy is like. So his accuracy, he made 15 of the past 26. So 15 out of 26. And we'll go to 1 decimal place, 0.58. So that's his accuracy. based off of the last 4 games. If he attempts 10, his accuracy, which is 58% or 0.58 times 10, go to 1 decimal place, equals 5.8 shots made. Now you obviously can't make 0.8 of a shot. So what you would say is between 5 and 6 made. And based off the fact that's 5.8, it's more than likely he makes 6 shots versus 5. How many shots is he likely to make this season if he attempts 180 foul shots? Exact same process. His accuracy, 0.58 times 180. Type that into your calculator. 104.4. So you can't make 0.4, so between 104 and 105 made. Now, even though I didn't ask it here, is this guaranteed? No, he could practice and get better, improve his accuracy. We're also assuming that how he was the past 4 games is how he's going to be for the rest of the season, which we know nothing in life is guaranteed. We're just trying to make predictions. That's what probability is all about, making predictions.